Okay, let me, in the next example, show you how to quickly graph a hyperbolic paraboloid. If you get an equation of the form z equals x squared divided by a squared minus y squared divided by b squared, that's an example of a hyperbolic paraboloid. Of course, you can interchange the role of any of the variables and get the same shape, different orientation of a hyperbolic paraboloid. Okay. So how do you graph this thing? It's a saddle. If you look at it for the right on the right set of x and y, it's a saddle. What does a saddle look like? Well, two of the vertical traces will be parabolas opening down. Think about it. If you let x equal a constant, you get z equals some constant minus y squared divided by y squared divided by b squared. That is a parabola opening down. So we'll draw it like this. Leave it a little short here for perspective reasons. And then draw another trace that's a copy of this one. Okay. Now, one trace, if you let y equal 0, you get one trace that's a parabola opening up because you have z squared equals x squared over a squared minus some constant. Okay. That's a parabola opening up. So that's one kind of trace. And in particular, you want to graph the one where y equals 0 to put the origin right in the middle at the vertex of that trace. Okay, and then there's a horizontal trace for the appropriate value of z that looks like a hyperbola. So two traces, notice the two kinds of traces I've drawn right now anyway, are parabolas and one other kind of trace, a horizontal trace, from a horizontal plane. Z equals a constant is going to be a hyperbola. So there's one branch of a hyperbola, and here's its other branch. And you've got yourself a saddle shape. Again, vertex right there. Now, keep in mind the way I've drawn it, the x-axis has to be in the computer screen. Coming out like so. That has to be the positive x-axis right there. Which makes, z is always pointing up. Positive z-axis is always pointing up. And to keep the right-hand orientation, that means the y-axis, positive y-axis, has to shoot into the computer screen. So there you go. That's a quick sketch of a hyperbolic paraboloid. Next, let's do hyperboloid of one sheet. One orientation you can get for that is if you have an equation x squared divided by a squared plus y squared divided by b squared minus z squared divided by c squared equals 1. And this will be the orientation where the z-axis is the central symmetric axis that runs through the center of this surface. And remember, this one, hyperboloid of one sheet, this is called, and it's the one that looks like a cooling tower from a nuclear power station. So how do we draw it? Well, I would draw one of the elliptical traces first, and then from there one of the hyperbolic traces. So hyperbola has two branches, one in this case going left, one going right, and then draw another elliptical trace. Oh, I can do better than that. Which you just get by plugging in a different value of z than whatever you used up here. But again, if you're just after a quick sketch, you don't need to specify exactly what values you're plugging in. Okay, let's try it again. There we go. It's a little bit better. And then there's also a trace that you would get that would be parallel to, well, depending on how you draw it, either the xz plane or the yz plane. You get a vertical trace coming out like that. But I kind of prefer to leave it the way I had it because it's kind of hard to draw that one. So I kind of prefer, and that one, this back one should have been dotted, by the way, but I plan on erasing it anyway. I think it just looks better like that. Okay, remember the origin is in here. So 0, 0, 0 is right in the middle of this thing.